and all of them are non-negative, right? Lambda and 1 minus lambda both turned out to be greater than or equal to 0. Let's generalize that, right? So how do I generalize? I equal to 1 to k theta I xi. This will be the convex combination. Theta I should be greater than or equal to 0 for all I, and lambda plus 1 minus lambda is 1. That means the coefficients, when you add them, you get 1. So here also, when you add the coefficients, you should get 1. Right? This is called the convex combination. In fact, if you take 3 points and take the convex combination, you will get all the points. If I choose different theta i's, I get different points inside the triangle. Right? Is that clear, everyone? So what do you mean by convex combination? Okay. Now this leads to what is known as the convex hull, right? So let's see what is a convex hull. What is a convex hull? What is a convex hull? What is a convex hull? So you took 3 points, took the convex combination of those 3 to get the entire triangle, right? So that process is called convex hull, or the set of all points inside the triangle, including all the 3 points, is called a convex hull of those 3 points. So how do you define that? What do you think is the how do you define? Any idea? How do you define this? Yes. How do you define the convex hull? Right? How do you define convex hull? Convex hull of x1, let's look at n points only, or k points, is defined as, well, I have to take all possible convex combinations of these k points and push that into the set, right? That's called the convex hull of, this is called conv of this set x1 xk, which is defined as, you look at all the convex combination of these k points. So how do I write that? I equal to 1 to n theta I, sorry, I equal to 1 to k theta I xi, such that summation over all I theta I is 1, theta I is greater than or equal to 0 for all I, right? So this is your convex hull. So in fact, if you take 3 points and do convex hull, you get the triangle, right? Is that clear, everyone? So this is how you do. So how do you do convexification of a general set like this? How do you do convexification of general set like this? Well, now remember, it may not be enough to take some 2 points and do convex hull. I can take any number of points and do convex hull, right? So in fact, this weird shaped non-convex set, if you want to do convex hull, you should take all possible points and do convex hull of all convexification or convex hull of all possible points, right? Then I get this set, right? That's called the convex hull. So how do you define this? Okay, let's do this. Okay, at least geometrically you understood what you mean by convex hull, right? For weird shapes also. Let's define this mathematically. So let you take any set. Okay, so I'll take some set. Okay, so take some S contained in Rn. It's a subset. Okay, the convex hull of S is defined as, you take all possible points, you take any number of points and do the convex hull of it, right? So that gives me this set. So how do you do that? One way is you pick any number of points, do the convex hull. Are there any other ways of doing it? Huh? So what I'm going to do is the following. Okay, so I'll just give you a different idea. I'll define it slightly differently. Uh, One way is, you take this ball, right? This is a convex set, but the original set is contained within this convex set. Okay, this is also a convex set, and this convex set contains the original set S. S is non-convex. Okay, I can keep on doing that, and I take intersection of all the convex set that contains this set, right? I can do that, right? So I'll define it that way. Okay, as intersection of all the sets, let's say I'll call this sets as C's. This C contains S. This is like uncountably many intersections I'm going to take. So when I take all the intersections, I get a convex set. Or equivalently, I can say, it is all those I equal to 1 to L theta I xi such that x1 through xl is contained in S. L is any natural number, right? And theta i's are all non-negative, and you sum this theta i's, you will get 1. Well, remember what are the variables here? So you give me L, right? The number of points to pick. I take those many points, L number of points from the set. I'll take all possible convex combination. I'll get several points, right? I'll throw into the set. Remember, the L points that I've chosen can be different, right? I'll choose some other L points, do the same thing. Keep on doing that for L points. Now you are not happy with L, you give me L plus 1. I'll keep on repeating the same thing again and again and again. I'll push all the points into the set. That's the convex hull, right? But geometrically, it's very easy, right? So what is the convex hull of, for example, this will be easy, right? What is the convex hull of this? This is definitely not convex set. So what will be the convex set? All the points, right? This is the convex hull of the convex set. So for example, if this is your S, right, this whole in red will be convex hull of S. I'll write it as conv of S. Is that fine geometrically? Okay. Okay, so now we know what convexification is. There is similar thing called conification. So what do you mean by conification? Well, this is just out of interest. We may not use it anywhere. But what do you think is a conification? Suppose I give you a point. What is the conification of this point? Huh? Convexification, where did we start? We started with convex combination. Then we took all possible convex combination to get convex hull. So if I give you 2 points, what is conification? I should take conic combination. So what is conic combination? See, basically you take all possible cones that contain these 2 points and take the intersection, right? So you take, for example, this. What are the cones that are possible? So suppose this is your axis. So then what are the possible cones? See, this is one possible cone, right? There is another possible cone, and so on. This is also a cone. Straight line is also a cone. Why? You take any point on the line, scale it, you will get a point on the line, right? So it's a cone. So of all possible cones, if I take intersection, what do I get? I get this straight line, right? So straight line is basically a conic hull of a point. What about 2 points? Suppose I have this. Let's say I have 2 points here and here. What is the conic hull of this? Yeah, so basically I have, this is conic hull, this is conic hull, and all the points between them is also, right? This is conic hull, right? I will leave this as an exercise. So conic hull, so as a reading exercise. So you should read and reading exercise. Okay. You will go through it, and those who will scribe these notes, they are going to read about conic hull and they are going to scribe that as well. Okay, slightly more, I wouldn't say challenging, but more work.